Okay, so on page 73, number 47 if you're using the white book, but if you're using your Chromebook, you go to page 75 in the ebook, and you're going to do number 55. It's the exact same problem, it's just the two different versions of the text. Just kind of see what kind of comes back to your memory on that.
There's no 55 on page 75. There's a 55 on page 76.
Well, okay, page 76 then. Page 76, sorry. Make that page 76.
Can we continue this on the page we did?
You sure can. That's why I said we'll just keep adding to that.
Wait.
I mean, no, we weren't talking about it. We were just talking about
Did you ever get in touch with Abby?
Well, we were just talking about people going to homecoming.
Yeah.
Wait.
Sit down. Her acting is so light is my favorite thing. Just you and Abby, y'all's acting towards everything is the highlight of my day. No, you and Grover last year, you got me. It was like, you're the first the other day, you're like,
Yup, there's pencil sharpeners, several people have asked. There's pencil sharpeners in two places up at the front and here. You do not have to ask permission to use those. Anything that's out, you know, it's yours. All right.
Isaac. Yeah, Scott, that random space doesn't need to be. Sorry.
Justin, did you check in? Justin?
Yeah, I checked in.
Because I was late, I told you. It's 27 inch. And it's that's what yeah. That's what I'm saying. The first one, I get it.
Well, duh, but like, for that, oh, yeah, I'll be
Hey, that's weird.
It has more neutron vibes.
So I think it's for, that's why, yeah, I have a question.
That means it has
Oh,
more.
we have to subtract 3.
Oh, that's
Yeah. Oh, because it's not the same number, so that's how you do the charge. Got it.
I get it, yeah.
Good observation. Yeah.
I mean, yeah, it looks pretty.
Okay, so this is the first one.
Where's the little benchmark? Oh,
It's what it says. But then this it has a 3 plus, so it's electronics.
Oh.
So this should be. So which is this one should be 4.
Y'all can fast forward to this part.
The opposite of 4, right?
Okay, remember, since we have so many people in here, we have to kind of take it down, work together, but we got to make sure we don't crescendo. If you're finished, you feel free to do that next one just for the fun of it. The 56. That generally that comes after 55. That would be the next one.
That's the mass.
That's basically the charge that would be on the ion.
That's protons. So that
So it's really going to be different between protons and electrons.
question, are we voting? So this is 70, this is wrong.
No, but I mean, it's just extra practice. I mean, if you can do 55, there's no need to do 56, but if you struggle with someone 55, you might want to practice 56. No need to do extra work.
Mass number is neutrons plus protons.
All right.
That's the neutron.
All right, we done?
So that means that we need to get the proton plus X is 59. X being the units. That makes sense. We don't have a half time? 32.
So that's just, you said 56 is just for the fun?
Yes. Oh, by the way, juniors. Juniors, you're supposed to join the classroom. I'm supposed to help you to do that. They should have gotten an email to join the junior class and classroom. Okay? Now, I tried to read off the code to my AO kids, and when they typed it in, it didn't work, but they copy and paste from the email, it works. Okay? So you need to join the junior classroom with the code from the email. So you doing 56 as well?
For some reason, I think they gave me the wrong.
Okay. All right. Let's look at this one. Okay. So let's take it down now. Let's refocus. Okay. How many of y'all would bet me a nickel you got this completely right?
I haven't done that one yet.
55. You haven't done this one yet?
I was looking
If I
at
had a nickel, I would bet it. I might have a nickel.
Help him, Lord. Just help him.
Will you actually give
Okay.
me a nickel?
So, cobalt. 3 plus. Does 3 plus affect the number of protons at all? No, because how do we make ions? Changing electrons. Okay, y'all, hey. Okay? So we got to change electrons. So, cobalt, how do we know how many protons it has? You look on the periodic table, it's right there, it's number 27. Okay? So, neutrons, how do we get neutrons? 59 minus 27 makes 32, right? And so electrons then, 3 plus, how do we make? Do we add or lose electrons? We lost electrons because electrons are negative, so we're taking negative away, so we're going to have a net 3 more protons than we do electrons, so we're just going to subtract 27 minus 3, so we're going to have 24 electrons. Okay, so the net charge is
3 plus.
3 plus. All right, now let's just talk about that 3 plus plus 3. Okay, you guys know that when you did naming in covalent compounds, that we have this thing called oxidation state. Okay, but when water makes H2O, hydrogen and oxygen is minus 2, hydrogen is plus 1, they balance out to equal 0. But there's really not a transfer of electrons because that's a covalent bond. They share electrons. So we say its oxidation state of oxygen is minus 2. That it's just 2 electrons are involved in bonding. The more electronegative element gets the negative sign for oxidation state, the less electronegative element, hydrogen, gets the positive. But it's not a transfer of electrons, it's sharing, and so it's oxidation state, so we say it's minus 2 and plus 1. In an ionic bond, though, or in an ion, there's actually a transfer of electrons. We actually have a charge on the ion. So then we say that the charge is 3 plus. So when the sign is afterwards, that implies that there's actually been a transfer of electrons to actually making an ion. That's a real charge. If the sign is in front, that means that it's really just the number of electrons that are involved in bonding. It's not necessarily meaning how many electrons have been transferred. Now for ions like sodium and calcium and magnesium, the oxidation state, the number of electrons it tends to lose, sodium tends to lose 1, so it's got an oxidation state of plus 1, but then when it loses that electron, its charge is 1 plus. It's going to be the same thing. Okay? It's just really in covalent bonding is where we have to differentiate. Now, on the periodic, on this chart here, it's wrong. They did minus, these are ions, but it's -2, -3, and whatever the sign's in front. It should be 2 minus, 3 minus. You will never, ever, ever lose points for having the sign in front or behind. Okay, so it doesn't need to be a stress point. But I just want to clarify, because sometimes they say, well, how do you know if it's 3 plus or +3? Okay, there is a very small semantical difference between the oxidation state and the charge, which is really important in covalent bonding. But it's not really that big of a deal, and you can put it either way. Okay, but there is a difference, but it's not that important. This is what I'm trying to get across. You following me on that? So don't stress about it, but there is a difference. So if it's a charge on an ion, the sign's last. If it's an oxidation state, like in covalent bonding, how many electrons are involved in bonding, then the sign's in front. Okay, so that's pretty easy. So now if it's 34 protons, we know this is what element?
No.
Selenium. Okay? I was going to make a stupid joke about can't keep my hands to myself or something from Selena Gomez, Selena. But anyway, I filtered it and said I shouldn't say it, but then I went and just did it anyway. So, all right. So 34 and 46, we know that we have 34 protons, but we have 36 electrons. So what's the charge?
2 minus.
2 minus. So we put that up there, 2 minus. So what's the mass number going to be?
80.
80. So we want to put that up there too. Okay? So coming over here, so 76 protons. We look over here. Now that one is osmium. Okay? And it's 116. So we know the number of electrons, since it's got a 2 plus charge, the number of electrons is going to be 74. So we put the 2 plus here, and what's its mass number? 192. And that goes up there. Okay? Curious to see how this comes out of video, but looking at this, it's got all kinds of colors coming off this board here on the screen. All right, and lastly, 80 protons is mercury, symbol Hg. Okay? Comes from the Latin. It's got 78, so what's the charge? +2 or 2 plus. Okay? And so the mass number, 200. So we're good. So we didn't do anything with ions yesterday. So I just wanted to make sure that we could do the same thing we did yesterday with the chart, but with ions. Any questions at all about that? We're good? Going once, going twice, going. This is so weird. I'm so distracted by this. But I was going to have it there, you know, whatever. But anyway, it's all right.
Does that turn by like motion?
It's following me. It's following this right here. It's pretty cool, huh?
That is so cool.
Yeah, modern technology.
Miss Florence, like,
Yeah.
I didn't know you that.
So I think that some of the stuff gets in the way and messes it up. Okay. I know.
You're talking about, oh my goodness, 2 minus 2 plus.
You're watching that.
So like if that was like a YouTube star, like that's what I would.
Okay, so thus far, y'all listen. We're classifying matter. We've gotten through elements. Okay?
Oh my gosh.
2 and 3 are a lot shorter. Okay? We're classifying matter. We went through elements. And we talked all about the different things about an element all the way through G. Okay? So now we're going to go, is this a big 2? Is this B? What is this? 2? Compounds. Okay? Compounds. substances that can be further broken down into simpler substances by ordinary chemical means. What does that mean, ordinary chemical means?
Burning.
Okay, heating it. Now, probably cooling generally doesn't break something down, but only if it's highly unstable. But just what I'm looking for one other thing.
What does it start with?
What chemical means. Okay, water or any other chemical which we would call a. This is real simple.
Chemical reaction.
Chemical reaction, okay? Heating or chemical,
That was it?
yeah, reaction, and that's my abbreviation for reaction, RXN. Okay? So ordinary chemical means, generally means you're gonna react it with something or you're gonna heat it up. Okay? You're not gonna do a nuclear change on it. You're not gonna do anything that's gonna change the composition of the nucleus. You're just gonna mix something with it, you're gonna do something to it, heat it up. Okay, add some chemical to it, make it break down. Okay, so now compounds. Okay, compounds are composed. Is this going to be a little a? What is this?
It's a little a.
Okay, composed of atoms of two or more different elements. Okay? So we can have molecules. Okay? Examples, we have carbon dioxide, H2O. Okay? C6H12O6. Okay? You have different elements. But so these are compounds. But if we had something like O2, N2, we can even have P4, you can have S8. These are not compounds. Why aren't these compounds? Okay? They're still molecules, but they're not different elements. Okay? So these are not compounds. They are molecular elements. Okay, and if you want to look like, let's see, white book, page 8, somewhere in the very beginning here. It's page 8 in the Chromebook. Let me just kind of throw that up there. Okay? So if we look at oxygen, this is two atoms of the same element. It forms a molecule, but you have to have two different types of elements in order for it to be a compound. Okay? So you can have molecules for both for elements and compounds, But a molecule is the smallest part of a compound is a molecule. You can't have atoms of a compound. You can have molecular elements, but you can't have atoms as molecules. Does that make sense? Follow me? Okay? So just, here's ethanol. Okay, just different molecules. This is all in your book. Okay? So the smallest part is a molecule. Now compounds can be ionic or covalent. Is it 15? No, that's them coming back from a lunch. Okay? Compounds can be ionic or covalent. So how do we tell the difference?
Non-metal or
So I go C, so what am I under here now? I?
Yeah, that's what I do.
Bullet, okay. Okay, so ionic, what type of elements combine to form ionic compound? A metal plus a nonmetal. Whereas covalent is going to be nonmetal plus nonmetal. Okay, so you remember now the metals are on the left-hand side of the periodic table, nonmetals are on the right-hand side of the periodic table. So, if I give you if I give you these compounds right here, and I'm going to ask, are these ionic or are they covalent? We can tell just like that. Okay? What's the only difference between ionic and covalent? The first thing's a metal here, first thing's a nonmetal there. Okay? So if the first thing, the metal will always be the positive. And when you write in the name or the formula, positives first, negatives last. Great life lesson. Always be positive first. First chance you have, be positive first. So positive always goes first, negative always goes last. In an ionic compound, the metals lose electrons, nonmetals gain electrons. So the metal's always positive, the nonmetal's always negative. So the positive will always be first. So you look at the very first element in the compound. Is it a metal or a nonmetal? This is a metal, right? Therefore it's an ionic compound. Okay? Carbon, nonmetal, so it's covalent. Potassium, it's a metal, so it's ionic. Carbon, it's nonmetal, so it's covalent. Magnesium, metal. So now we have NH4 plus. What do we know about that one? What's the name of that? Ammonium, whoever said that, that's right, ammonium, that's the ion, that's the only polyatomic cation, or positive ion, but it's still an ion. So if the first thing's an ion, this is going to be ion. So that's an ammonium ion plus the sulfate ion, so it's going to be ionic. Okay? So we can always just look at the first thing and know whether it's ionic or covalent. That's going to be huge for us the rest of the way. Now we can have metallic bonding as well, but that's going to be an element because it's just going to be a pure metal, pure gold bonded to gold, bonded to gold, silver bonded to silver, bonded to silver, and so those are just going to be elements, but it'll be metallic, but we can tell that if it's just pure metal. Then we'll have a special type of compounds called covalent network, but there are only like 5 of them. We just memorized those 5: diamonds, graphite, silicon carbide, silicon dioxide, and silicon itself. So we'll just learn those when we get into bonding. But generally, everything is either going to be ionic or covalent. And we're just going to look at that. Okay? So, compounds you just look at, we have ionic and metallic. So in ionic compounds, I should have done this better, but live with me. I'll make up for it. This is going to be D. It's little d, right?
Yes.
Okay? Ionic compounds are described by what type of formulas? You have two types, empirical or molecular? Empirical formulas while covalent compounds are described by molecular formulas. Now the reason for this is because ionic compounds don't really form molecules. Ionic compounds form these big, huge crystals. Okay? So when we're about to go to lunch, okay? And so there's salt. 1 grain of salt is going to have billions and billions and billions of these Na pluses surrounded by Cl minuses, surrounded by Na pluses, surrounded by Cl minuses. So we don't have a set unit. We don't have an individual thing. We have this huge crystal. And so all we do is give the ratio, the simplest ratio of how they combine. It's called the empirical formula. Empirical means simple. Okay, the simplest formula. But covalent compounds form molecules like water, H2O, or carbon dioxide, CO2, where we have distinct individual units, and so we use a molecular formula to describe those. They do not have to be in the simplest ratio. For instance, C6H12O6. That could be reduced to CH2O. But the molecule actually exists as C6H12O6, and so as a result, we write the formula the way the molecule really is. It doesn't have to be in the reduced form. Ionic compounds is always the reduced form, the empirical formula, whereas covalent compounds, we write it as the molecule really exists. Could be the reduced formula like water, H2O, or CO2. All right, we'll go to B lunch today. Normally now that we're going to go on Wednesdays, we're going to do D lunch, bring a snack, okay? So come back whenever this lunch is over.